If you think DeepSeek crushed the market and caused serious political and financial debates across continents, wait to see OmniHuman 1, a video generative model that produces incredibly realistic videos like you have never seen before. And no, Sora doesn't even come close. All the videos that I'm showing here are generated by OmniHuman.
And just there are options out there, but don't just stick for the song that everyone thinks is amazing. Back in the 80s, man, remember? No man, no man. So
OmniHuman is an end-to-end AI framework developed by researchers at ByteDance in China. It can generate jaw-droppingly realistic human videos from just a single image and a motion signal such as audio or video or a combination of both as a guide. I say it's incredible because OmniHuman generates realistic human videos at any aspect ratio and supports various portrait content such as face close-ups, portrait, half-body and full-body shots, supports both talking and singing, handles human-object interactions and challenging body poses, and accommodates different image styles. OmniHuman can also mimic specific actions from reference videos. These features make it versatile for different types of content and creative applications such as animated movies or interactive gaming. OmniHuman is a diffusion transformer-based framework that scales up data by mixing motion-related conditions into the training phase. But before I tell you about the model's architecture and main methods in the research paper, let's take a look at some of its impressive outputs. In this example, a simple image of Einstein is given as input and OmniHuman has turned it into a fully integrated audio-video output with a realistic tone of voice, lighting, and facial expressions down to breathing patterns. Take a listen.
What would art be like without emotions? It would be empty. What would our lives be like without emotions? They would be empty of values. So a famous classical poet said, "We hate and we love. Can one tell me why?" Catullus. Science does not answer why questions.
Here's the second example of a half-body image as input that is turned into a video with realistic hand movements and body gestures.
I work when I get the accolades, when I go in fleets and flights, and when people say that they have read my autobiography or they have read my books, then I understand.
This one is even more challenging because the subject in this portrait image is wearing a mask. So the model has to account for possible breathing and speaking patterns and their effects on the mask as a soft class object. What's even more amazing is the realism and consistency in the background scene of the passers-by and moving cars. But that's not all. OmniHuman can also generate artistic videos from animations with diverse outputs such as cartoons, artificial objects, animals, and challenging poses, ensuring motion characteristics match each style's unique features. Look at these generated videos and tell me if you don't want to start your own Disney tomorrow.
Yes. This is his position, in 2 words. A little while since he obtained an excellent offer of employment abroad from a rich relative of his, and he had made all his arrangements to accept it.
Oh, nothing. Just, stretching before we hit the aisles. Shopping is the #1 cause of pulled hamstrings. Well, I didn't know that.
Easy. Everybody can be boring, but you're gooder than that. Life is not a game, people. Life isn't a cereal either. Well, it is a cereal. And if life is a game, aren't we on the same team?
If you stayed so far, it means you're looking for some information about the model's architecture and the main methods behind this fantabulous generation. As you can see in this image, the OmniHuman model consists of 2 parts, a multi-condition diffusion model and the Omni-Conditions Training Strategy. The model uses a multi-modal diffusion transformer. This means it can support simultaneous conditioning with multiple modalities including text, image, audio, and pose. This model is trained on general text-video pairs for text-to-video and text-to-image tasks. Given a reference image, the OmniHuman model aims to generate human videos using one or more of the driving signals including text, audio, and pose. The paper details the strategies they have used to integrate frame-level video, audio features, and pose heat map features into the OmniHuman model. To learn the video denoising process, it projects videos at their native size into a latent space and employs flow matching as the training objective. The Omni-Conditions Training Strategy employs progressive multi-stage training based on the motion-related extent of the conditions. The mixed condition training allows the OmniHuman model to benefit from the scaling up of mixed data. During training, different modalities are activated for different data, allowing a broader range of data to participate in the training process and enhancing the model's generation capabilities. As you can see in this image, two principles are used to scale up the conditioned human video generation task. First, stronger condition tasks can leverage weaker condition tasks and their corresponding data to achieve data scaling up during the model training process. And second, the stronger the condition, the lower the training ratio that should be used. Here you can see the ablation study on different audio condition ratios, where the models are trained with different audio ratios for these sounds. Ablation is the removal of a component or certain parts of a network of an AI model to understand its contribution. This series of images also show the ablation study on different pose condition ratios, where the models are trained with different pose ratios. It can also generate anthropomorphic images, as you can see, and even make a human into an animal or inanimate object. As for now, we have little information as to when they would release the model and if they decide to make it open source. I for one hope for this model to become open source. Let me know your thoughts on this and if you'd like a more detailed video about its architecture.